All right, so if you can turn to page 23 in your Unit 4 packet, today we're going to talk about something called imaginary numbers. And just to give you a little heads up, an imaginary number or the imaginary unit is when you have a negative under the radical. So we'll get to that in a minute. Okay, so let's take a look at number 1. Now, number 1, actually, the directions for 1, 2, and 3 all say to solve for x. So number 1 says x squared minus 25 equals 0. Now, you could go about solving this a couple different ways, but what happened here was in order to solve this, they added 25 to each side. So the negative 25 and positive 25 canceled off, and it left us with x squared equals 25. And then we know to get rid of a square. I'm going to show this here. We could take the square root. Okay, so what happens is a square and a square root cancel each other out, leaving you with just an x. And then this square tells us we could have two answers. So that's why the plus and minus is here. And then the square root of 25 is 5. So we wind up with x equals positive 5 and x equals negative 5. If you were to substitute either one of those answers back into this original equation, they would both check out. Okay, so let's solve number 2 and number 3 the same way. So number 2. All right, so I'm going to first add 8 to both sides of the equation. So when I do, that's going to leave me with x squared equals positive 8. Okay, and again, to get rid of a square, we take the square root. So that's going to leave me with x equals, and that square tells us we could have two answers, so plus and minus. And since 8 is not a perfect square, like in number 1, 25 was a perfect square, so we just basically made it into a 5. Since 8 is not a perfect square, we're going to simplify that radical. So we're going to find two numbers that multiply to 8, where one of them is the biggest perfect square possible that divides evenly into 8. So that would be 4 times 2. Okay, 4 is the biggest perfect square that divides evenly into 8. And since the square root of 4 is 2, I could rewrite this as x equals plus and minus 2 radical 2. Okay, I'm going to just basically take the square root of 4 and make that a 2 and bring down my radical 2. So now these are my two answers. X equals positive 2 radical 2 and x equals negative 2 radical 2. If I plug either one of these back in for x, this equation would check out. All right, so now let's do the same thing with number 3. So this time we're going to subtract 9 from both sides of the equation because it's x squared plus 9 equals 0. So that's going to leave us with x squared equals negative 9. Okay, now this time when we go to take the square root, it leaves us with x equals plus and minus. Well, look at this. We have a negative under the radical. And this is what I was saying before. A negative under the radical is equal to what we call the imaginary unit, I. So when you have a negative under the radical, right, I'm first going to break this down into radical positive 9 and radical negative 1. Okay, and what I did was basically 9 times negative 1 gives me negative 9. And I wanted to get this radical negative 1 by itself. Because if you look up here, the square root of negative 1 is equal to I. So basically, just like I could cross off this 9 and make it a 3, I could cross off this radical negative 1 and make it an I. Okay, so it's going to leave me with x equals positive and negative. Again, the square root of 9 is 3. And the square root of negative 1 is I. So it leaves me with positive 3i and negative 3i. Those are my two solutions. Okay, so I'd like to show you something in the calculator first. If I were to plug in the square root of negative 1. Okay, first of all, if I hit enter, at first it says non-real answer. And that's true because the square root of negative 1 is a non-real answer. It's an imaginary unit. So what I'm going to do is, let me just clear out of here for a minute. I'm going to go in my calculator. There's a mode button right here. I'm going to go to mode. And if you look down here, see where it says real? I'm on real numbers only. If I change over here, it says, it's hard to see, but see that little I? It says A plus BI form. This I allows you to, allows your calculator to take into consideration imaginary numbers. So I'm going to hit enter on that. And then, when I clear out of here, watch what happens. The square root of negative 1 is I. So there we go. Okay, and one more thing that I want to show you. There's an I button in your calculator. If you look down, see on top of the decimal right here, there's a little I. if you hit the second button and then the decimal point, it'll type I in your calculator. So if I wanted to check, let's just say the positive 3i, if I plugged in positive 3i where I saw the x, so you know what I'm going to do? I'm just going to put in parentheses, I'm going to type in 3, and again, the I is second decimal, and I'm going to close the parenthesis and square it, and then hit plus 9. So basically what I'm doing is I'm mimicking this equation, but I'm plugging in positive 3i for x. So I have 3i squared plus 9, and when I hit enter, watch what happens. It's equal to 0. So positive 3i is one of the solutions. And if I did the same thing with negative 3i, it would check as well. Okay, so let's take a look at some of the examples on the bottom of the page. Now, the directions just say to simplify. So I'm going to do 4 and 5 with you, and then 6 and 7 will be classwork for tomorrow. Okay, so number 4. Now, what I'm going to do here is I'm going to basically try to simplify what's under the radical. So let me start by bringing this 2 down, and then I'm going to break up the radical negative 49 into 2 separate radicals. I'm going to put positive 49 in the first and negative 1 in the second. And the reason I do that is because I know the square root of negative 1 is an I, so basically I'm kind of getting the negative out of the radical. Okay, so let me bring down the 2. We know that the square root of 49 is 7. Now, what do I do with this 2 and this 7? Well, this means 2 times radical 49, so I'm going to have to multiply these. For right now, you could either put a multiplication dot or you could put parentheses. Either one means multiplication. And then we already learned that the square root of negative 1 is I. So now, if I multiply this together, it leaves me with 14i. Okay, that's what this expression simplifies to. Now, one thing I want to point out, I know in the examples above, let me just slide those back up here for a minute. I know we were writing plus and minus. And the reason we were writing plus and minus is because we were solving an equation that had an x squared. That means we could have 2 solutions, okay? The positive and the negative solution work. But in numbers 4 through 7, it's just saying simplify. Okay, if you have a positive in front of your radical, you will have a positive answer. If you look down at number 6, yeah, there's a negative in front of our radical, we will have a negative answer. Okay, let's take a look at number 5. So I'm going to do the same thing. I'm going to bring down the 2/3. Now, technically, I could break this down. Don't write this yet. I could break this down like I did the last one into radical positive 18 and radical negative 1. But 18 is not a perfect square, so I'm going to have to break that down further. So rather than doing it in the next step down, what I like to do, I'm just going to erase for a minute. If we have a non-perfect square like 18, right, under the radical, instead of initially breaking it up into 2 radicals, I like to break it up into 3 radicals. Okay, you could put the negative 1 wherever you want. I'm just going to put it at the end here. Okay, so this negative is at the end. So really what we're doing is we're breaking down now a positive 18. So you want to, in these 2 radicals, you want to figure out what's the biggest perfect square that divides evenly into positive 18, and that's what you're going to put in the first radical, which is going to be a 9. And then since 9 times 2 gives us 18, 2 is what we're going to put in the next one. Okay, so let's bring our work down. I'm going to bring down the 2/3. Oh, let me get the pen. 2/3. Now we know we have multiplication, so I'm going to basically open a parenthesis. And the square root of 9 is 3, so I'm going to put a 3 in here. Now, I'm going to cross that off just to show I used it. I'm going to skip this one for now. I'm going to jump over here. We know the square root of negative 1 is I, so I'm going to cross that off, and I'm going to put my I next to the 3. Usually what happens is you put your I next to your whole numbers, like we did here, and whatever radicals we're left with, we just bring down at the end. So the radical 2 I'm going to bring down at the end. Now, all I have to do to finish this is just multiply 2/3 times 3. Now, isn't 3 the same thing as 3 over 1, right? So if I were to multiply these, you multiply the tops and multiply the bottoms. So 2 times 3 is 6, and 3 times 1 is 3. So 6 divided by 3 simplifies to 2. Or even easier, I like to say this. Doesn't this 3 on top cancel with the 3 on bottom, leaving me with a 2 over 1, which is just 2. So I have 2 and then I, and I don't need the parentheses any longer, and then I can bring down the radical 2. So 2i radical 2 is what number 5 simplifies to. Okay, if you can turn to the next page. Now we're going to talk about complex numbers. A complex number is just when you take any real number, like 7, and you add or subtract it to any imaginary component, like 2i. So 7 plus 2i, this right here is called a complex number. Okay, or if you look next to it, where it says 3 minus I, 3 is the real component, and then the negative I is the imaginary component. So this is called a complex number. Now, something that we have to memorize, something that you really need to know, is that I squared is equal to negative 1. Okay, put a star next to that in your notes. That's important. Okay, I squared equals negative 1. And it kind of makes sense, because think about it. If I'll do this off to the side, if I equals radical negative 1, okay? If I take this I and square it like we have here, then I have to square this side of the equation. And doesn't a square and a square root cancel each other off, right? So basically, we'd be left with negative 1. So I could bring down my I squared equals, and then again, since a square and a square root cancel each other off, I'm just going to bring down the negative 1. So I squared equals negative 1. Okay, so basically you're going to keep this rule in mind as we do some of the examples on the next couple pages. So the next couple of pages, all they want us to do is take complex numbers and perform certain operations on them. So for example, number 8 says, which expression is equivalent to this binomial here squared? Now, when you have a binomial being squared, or anything being squared, right, doesn't that mean there's 2 of them? So let's take this binomial, 3k minus 2i, and let's write it out twice. Okay, that's what it means when something's squared. We have 2 of them being multiplied together. Okay, well, if we have a binomial times a binomial, we can just go ahead and double distribute. So let's do that. Okay, I'm first going to distribute the 3k to both terms. So 3k times 3k would be 9k squared. And then 3k times negative 2i would be negative 6. And then I'm going to arrange this as ki. We usually put the I at the end. So negative 6 ki. Okay, now we're going to distribute the negative 2i to both terms. So negative 2i times 3k would be negative 6 ki. And then negative 2i times negative 2i is going to be positive 4. And then I times I is I squared. So positive 4i squared. Okay, so now what we're going to do is we're going to see what we can combine here. Now, I'm sure right away you guys see that we can combine the negative 6ki and the negative 6ki, okay? Those are like terms. So since negative 6 minus 6 is negative 12, I'm going to combine these to give us negative 12ki. And for right now, let me just take this 9k squared and just bring it right down. Okay, now, do you remember before when we said that I squared equals negative 1? Okay, here, since I squared, let me just put this, since I squared, right, is equal to negative 1. Doesn't that mean that we have a 4 times, I'll put it in parentheses, 4 times negative 1? So wouldn't 4 times negative 1 just be negative 4? Okay, again, 4 times I squared. Since I squared equals negative 1, 4 times negative 1 is negative 4. Now, if we look here, there's nothing left to combine, so let's see which answer choice says that. All right, we see it right here in choice number 3. Okay, and if you go to the next page, I'm going to take a look at number 11 with you. All right, so this one was a multiple choice question on the region, just like the last one we did. And this one's it's pretty much the same thing. It's asking us which, this expression is equivalent to which one of these. Okay, so again, just like the last one, we have an expression being squared. So that means we're going to write it out twice. So let me first bring down the 6 minus. And then I'm going to write the 3x minus 2i twice. Okay, so we have 2 of those being multiplied together. All right, so I'm going to bring down the 6 minus, and let's double distribute this out. So 3x times 3x is 9x squared. 3x times negative 2i. This is very similar to the last one, huh? It would be negative 6xi. It's just using an x instead of a k. Negative 2i times 3x would be negative 6xi. And negative 2i times negative 2i would be positive 4, and then I squared. Remember, I times I is I squared. Now, if you look at how I have this written, there's a mistake. And I don't know if you guys see the mistake. But if you don't see it, we want to do 6 minus this entire product. The way I have it written is I'm just doing 6 minus this first term. If I want to subtract out this entire product, I need to keep this whole thing in parentheses. Okay, because I'm eventually going to need to distribute the negative to each term. And if you want to do that now, go for it. You could do that first. So we'd have 6, and then I'm going to distribute this negative to each term. So negative being distributed to the 9x squared would make it a negative 9x squared. A negative times a negative 6xi would be positive 6xi. A negative times a negative 6xi again would be a positive 6xi. And a negative times a positive 4i squared would be a negative 4i squared. Okay, so let's, I guess first we know that this I squared is equal to negative 1. So isn't negative 4 times negative 1 positive 4? Okay, I'm going to make that a positive 4. Again, I squared is equal to negative 1. So negative 4 times negative 1 is positive 4. And then I'm kind of working my way backwards here. Let me combine these like terms, and they'll give me positive 12xi. And for right now, I'm just going to bring down the 6 minus 9x squared. Okay, so again, what I did in this step was I brought down the 6, I brought down the negative 9x squared, I combined these two terms to give me positive 12xi, and since we know that I squared is equal to negative 1, I did negative 4 times negative 1, which is positive 4. And then it looks like from here, I mean, we could still combine like terms. Look, we have a 6 and we have a 4. So we can combine those to make them a 10. So I'm going to put that at the end because there's just like a number all by itself. So I'm going to have a negative 9x squared plus 12xi. And then when I combine my 6 plus 4, that's going to give me positive 10. Okay, so that matches up with choice 1.